boop 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 boop. Back.
I was right, but then you doubted me, and then we came back on the right side.
I actually didn't doubt you when you were wrong, and then I doubted you
When I was right.
Yeah.
That's typically what
Okay.
happens.
All right.
No, it's fine. It's
Okay.
fine. On the bright side, we made it out of the forest,
We did.
and here we are.
Yeah.
Who are we?
We're the periodic round table.
Perfect.
Yeah.
Who are you?
I'm Brittany.
Who am I?
You're Joel.
Perfect. All right. Well, let's get started.
Is this a test to see?
Oh,
if
no.
I'm
This was
one?
the intro.
Yeah. Okay.
Did you listen to the last intro?
I did.
We're not changing this one either.
Okay. Excellent. Excellent.
You should know by this point we just jump in.
All right.
It's-
We jumped right in.
Why do we need to warm up
Yeah,
anymore?
exactly.
Do you need to warm up?
Oh no, I'm good.
Do you want to restart?
No, I'm good.
Oh,
Let's
okay.
go. Let's
All right. Let's do
start
this.
Our climate change series, our 3-part climate change series.
3-part. This is going to
Yeah.
be quite the series.
Yeah. So
Well, Brittany, if we're going to do a 3-parter, I feel like at first we need to discuss some of the background, the definitions, the development of how we observed climate change.
So a lot of people may not actually understand climate change too thoroughly. Still, even to this day, people get global warming and climate change confused. So climate change actually refers to the changing of the climate systems and subsequently the weather patterns such as temperature, precipitation, wind patterns, and this has a long-term effect lasting decades or more. The difference between global warming and climate change is something of a contentious point. They're often used interchangeably, but they describe two distinct phenomena. So global warming describes the rising global temperature throughout the 20th and 21st centuries, whereas climate change describes not only the rising temperature from global warming, but also extreme weather events such as stronger hurricanes and tsunamis, rising sea levels and flooding from ice cap melt, ocean acidification, alteration of vegetation, for example, replacement of tropical forests by savannas, and mass extinctions, among other effects. So we're going to delve deeper into these effects over the course of this entire series.
Man, that's a lot of things to talk about, Brittany.
It's a lot of
We're
things to talk
really
about.
going to talk about all these things.
We are. That is why we are breaking this up into 3 different
This is a
episodes.
lot of sad things, Brittany.
It's a lot of sad things, but honestly, people need to know. They need to be aware. They need to have their awareness raised, and they need to stop falling for the lobbyists and the politicians going against the idea of man-made climate change.
I would like to think that most people are aware of these problems and are willing to adhere to truth and information that's available rather than following blindly
Yeah.
the lobbyist. And
You know where I'm from, right?
I know.
Yeah,
I
I'm
know.
from a deep red state, so
Oh,
yeah.
man.
Uh-huh.
Wow. If your family heard you today.
Oh, yeah. They'd be so
okay.
disappointed.
They would be. But let's see. We have climate change, right? And then sub below that is global warming, because global warming is a part of the climate change.
Exactly.
Right?
Yeah.
So not interchangeable.
Right.
When people are like, oh, see how cold I am? This can't be global warming.
Yeah, every time you see like a huge blizzard hit, you always see people, where's the global warming this time? And the idea is that the average global temperature is increasing, but in turn that's causing extreme weather patterns, so you might actually see more extreme blizzards because of climate change.
Well, that's one of the problems that we have in Florida is all the hurricanes just ramping up in severity. Rather than having a whole bunch of tropical storms in the past, now we're just hurricane after hurricane.
Right.
Battered down, beaten, slapping us around. It's all right. That's why Floridians like it so much.
Oh, yeah,
Just-
they do.
I like a nice slap to the face, more metaphorically.
Oh, okay, yeah, and non-metaphorically. Okay.
Brittany. Back to science. Back to science. We have a whole bunch of people, right?
Right.
That point out all of this information about it not being warmer and global warming, climate change, all of this and that, right?
Yeah.
And then we
Fake
have
news.
all these scientists, these bullshit scientists
Bullshit
who are
scientists.
paid to research these things and say these things. So obviously they're going to lie in order to save their jobs.
Absolutely not. Absolutely not.
So you're saying scientists aren't wrong?
No. The short answer, are scientists wrong? No. Absolutely not. So we're going to get into the longer answer.
All right, let's get into the longer answer. When did we realize that scientists weren't wrong?
Okay, so this actually goes back quite a ways into the 19th century. So in 1896, there was a Swedish physical chemist known as Svante Arrhenius, and he calculated the extent that carbon dioxide emissions from burning fossil fuels would raise the global temperature when looking to explain ice ages. And he was able to conclude that human-generated CO2 emissions would be enough to cause global warming through the greenhouse effect. However, many argued against his model, and the theory was temporarily put to rest.
Much like many theories that have been put to rest and then had to be resurrected after society was ready to accept the ideas.
Yeah, exactly. Yeah. But his idea surfaced again in the 1930s. So in 1939, there was an English steam engineer and inventor, Guy Stewart Callender, and he revisited Arrhenius' theory by compiling temperature measurements from the 19th century onward, and he correlated these with the atmospheric CO2 concentration measurements.
Whoa. 1939.
Right.
English steam engineer.
Yes.
With what better name than being a Guy
Yeah.
or a Stewart or a Calendar?
Yeah, he has a great name, doesn't he? Yeah.
All right, I just want to make sure. I can see his effect, right? So he's a guy. He accepts that he's just an individual person, right? He's a steward for truth and knowledge.
Yes.
And he's always temporally appropriate. I just like the name.
Okay, yeah.
Unimportant.
The
I
name
know.
is great, yes.
I thought so as well. I'm glad you agree, Brittany. glad we can both agree on this.
Yes.
So, 1939.
Yes.
In England, the hot, steamy, swampy parts of England, where Calendar was working day and night, sweating profusely. He figured some of these things out, right? But let's move forward. How did we progress past that?
Okay, so past that, scientists began looking more thoroughly into the models in the 1950s, and this was due to increased military funding from Cold War going on. And there was an American atmosphere scientist, Dr. Charles David Keeling, and he collected CO2 data over 2 years at the Mauna Loa Observatory in Hawaii, and he produced his Keeling curve, and this showed a steadily rising carbon level in the atmosphere. And a continuation of this curve actually continued throughout the years up until 2018. And it's starting to show a slight acceleration.
Acceleration, you say. So we're increasing it faster and faster as we're going.
Right.
But this was back in the 1950s.
Right.
Where he did 2 years of research at Mauna Loa.
Mauna Loa.
Oh, man. I would do 2 years of research at Mauna Loa.
Yeah. It was just an excuse.
So he found these curves of increasing CO2, right? So this curvaceous increasing,
Yes.
meaning that these greenhouse gas effects that Arrhenius was talking about earlier are propagating,
Yes.
right? Okay, so this is just one aspect
Right.
of climate change.
Yes.
right? I'm focusing. Yes.
You are very fidgety today.
I don't know why.
There's all the background noise. It's not me.
I just wanna
it's
touch
Joel.
things right now.
It's Joel just throwing shit around the studio. Anyway.
Anyways,
Yes.
rising concern throughout the 1970s, Brittany.
Yes.
I believe scientists argued something about global warming.
They did. So some scientists actually argued against global warming in the 1970s, and they settled for the global cooling theory instead. This is due to the aerosols that were in the air. They thought it would cool it down. So there was a meteorologist, Dr. Reed Bryson, and he was one of these proponents. And when he was faced with the knowledge that the temperature of the planet was, in fact, increasing instead of decreasing, he went on to argue that it was not man-made, but a natural end to a little ice age.
I see what you're saying. So we have this meteorologist who argues that it was the end of a little ice age, which is something that I'll hear in the counter-arguments against climate change.
Oh, yeah, it's a very common argument.
Is that, it's a natural occurrence.
Yes. Yeah, it's not us. It's not us. It's supposed to be happening. Don't worry about it.
Fascinating.
Carry on. Yes.
From aerosols. So you're telling me that back then they would have thought all the hairspray
Exactly.
in the 70s.
Exactly.
Because you know how much hairspray there was.
Oh, yeah. A lot of Aquanet.
Oh, man.
Yeah.
I can see that cooling it down.
Oh,
right?
yeah. Anyway.
I'm listening.
So, we went on to further along, and they started using computer models in later years to predict jumps in temperature. So there were improved computer models, and they predicted these much larger jumps in temperature as well as extreme weather effects. So in 1988, there were hundreds of scientists gathered in Toronto for the World Conference on the Changing Atmosphere Implications for Global Security conference. And they concluded that the threat humans were having on global temperature and climate was pretty severe. So there was a large push from the scientists themselves to start really looking into what we can do about the rising temperatures. But in return, there was a large pushback from corporations and the general public that were against government regulation.
Yeah, Brittany, but what have the scientists done for me lately? Have they put more money in my pockets? No. They helped develop the EPA, which, mind you, 1972, by one of the most glorious presidents that the U.S. has been able to have.
Yeah.
Sweet, sweet Nixon.
Yeah.
Oh, dirty Dickie.
Yeah.
Listen, he did a lot of things. One of them was make the EPA, okay?
Okay.
Which was a valuable aspect.
Yeah, that was valuable.
It was a lot of strides in order to mitigate some of the problems that we've had. And let me tell you, after going to India, man, I won't get into it now, but one of the first parts is when I went to Delhi, and I was so excited. I walked outside, and the doors were still closed at that point. I looked out, and I was like, wow, it's so foggy this morning as I arrive at 5 a.m. No, Brittany, it was not fog. Pure poison seeping through the air, okay?
Ugh.
So the fact that a lot of people are like, oh man, the EPA is just destroying our economy by putting too many regulations on our corporations. Oh man, so wrong.
Yeah.
We have saved the health problems of so many people just by putting these regulations
for sure, not
on.
just with air pollution, but with water pollution as
Oh,
well.
that too.
Yeah.
All the dumping.
Yeah.
So I can see that the corporations, right? As time and time again, we have been shown that lobbyists for these corporations see only one thing in their eyes. That sweet, sweet bottom ass slapping dollar.
Oh yeah.
So
The money.
they had pushback. Scientists still arguing for the truth about all of these changes, trying to push forward the legislation so that we can actually increase the regulation in order to save future resources for people, right? Okay. And that was in Toronto.
It was.
Okay.
Yes.
Now, that back in the 80s, we've come a long way since the 80s, I would like to think.
I would like to think.
Oh,
Yeah.
I don't know if we have. What have we concluded lately? After Toronto.
Yeah, so lately, the scientific community kept pushing for looking further into this. And in 2007, they concluded that the average global temperature would increase by 1.4 and 6 degrees Celsius by the end of the century. So for those of you not familiar with Celsius, that is 2.5 to 11 degrees Fahrenheit by the end of the century. So everybody who's bitching right now about how hot it is, imagine about 10, 11 degrees higher. It's going to just get worse unless we do something.
Is it too late to do something?
Well,
I don't know.
I don't know. That's further along. That is episode 3.
That's episode 3
of the series.
Doomsday.
Yeah.
The Doomsday.
Not doomsday, but what we can do about it.
Right. But the point is, shit's happening.
Oh yeah, there's definitely something happening. There's been stuff happening for a long time. Scientists have known about it for a long time. And a lot of people continue to deny it.
It's just like many other things, right? We develop things in a lab and we get them all ready to go and people are all excited, but it still takes decades even for either information or technology to seep through the rest of the minds of society,
right,
so that people can have an agreement. Oh man, let's not even talk about how long civil liberties took to get.
Oh yeah, for sure.
Women's suffrage?
Yeah.
So long. So long.
Yeah.
So I can't even comprehend how long it'll take for the vast majority of society to accept these inevitable changes that are occurring all around us. Literally all around us.
Yes, all around us. Luckily, lately, I personally feel like a lot more people are starting to open up to the idea that, maybe these scientists know what they're talking about since that's their jobs, is to look into this. Oh, they're not paid millions of dollars. Interesting.
Interesting how that works.
Yeah.
Well, you also live in a college town instead of West Virginia, so perhaps your viewpoints have altered.
Yeah, maybe just a little bit.
No, I don't think we need to convince anyone. I'm pretty sure everyone that listens to this podcast, Brittany, already agrees.
Yes.
But let's talk about some of the parameters that they actually use to test these changes.
Right, so we can look into how scientists actually discover evidence of climate change. So there's 5 different parts of the climate system that they can investigate. There's the atmosphere, which is the air. There's a hydrosphere, water. There's the cryosphere, which is ice and permafrost. There's the biosphere, which consists of life. And then there's the lithosphere, which is the crust and upper mantle. So the first of these analysis can include ice sheet mass analysis. And this can be done through satellites. So, for example, NASA's GRACE satellite has collected data on ice sheet mass in both Antarctica and Greenland since 2002. And what they've observed is this alarming loss with a heavy acceleration since 2009. So Antarctica has lost 127 plus or minus 39 gigatons of ice since 2002, whereas Greenland has lost even more. It's lost 286 plus or minus 21 gigatons. Gigatons. Not just tons, gigatons.
So, like 200 something gigabytes of just pure, raw, unfiltered porn sitting on my hard drive. It's gone. Just wiped away.
Yeah.
But in ice form.
In ice form.
Right.
Yeah.
Ice porn.
Yeah.
Right?
Oh my God.
Listen, we're losing it. We're
Yeah.
losing it.
Uh-huh.
Okay. Glaciology is an important study. Feminist glaciology is underrated. Okay. The male gaze is
Yeah.
melting.
I recommend everybody look up feminist glaciology. Please do it. You will be delighted.
Will they, or will they shake their heads in shame and never trust another scientist?
Both? Why
That's
not
true.
both?
I will say no. No, I don't think it was a scientist. I'm pretty sure it was a sociologist that wrote that
Sociologist.
research paper.
Are sociologists really scientists?
Listen, we're not into that debate right now. Okay,
Okay.
you already upset all of the engineers.
Engineers.
Last week. All right, so we have NASA, whom may or may not be lying to us about the round Earth theory.
They're not lying to us.
And we have the ice sheet mass analysis. Now, what I am especially concerned about, because it affects one of my favorite creatures, the polar bear, which unfortunately has had to migrate to further places and find more, let's say, bountiful resources.
Right.
The big, rumptious black bear. And then they catch each other's gaze off in the distance. The polar bear had to swim across many frozen glaciers, which is water, and it had to find land again. But there was someone there waiting, someone beautiful, big old brown ass, and they made the Pizzly Bears. But despite my enjoyment of the Pizzly Bears,
Yes.
the glacier's melting, Brittany.
So there are a lot of studies of glacial melt. There's one study in particular that I wanted to bring up. So there was a really large study where scientists investigated glacial melt in the Tian Shan region of Central Asia. And the glaciers here are really important freshwater sources for several countries in this really arid, dry region. So it was found that the glaciers are losing 0.1 to 0.8% of their surface per year. And that's predicted to lead to an increase in winter precipitation and a decrease in summer precipitation. And in turn, this will lead to widespread droughts in an area that's already extremely arid. So these people are going to have no access to fresh water over the years as this goes on.
Wow.
Yeah.
0.1 to 0.8%.
Yeah. It doesn't sound like a lot, but when you think that's per year.
Well, no, per year, that's a lot. So let's imagine, right, that we look at just the front of your arm. What's your favorite arm?
My favorite arm?
Your favorite arm.
Probably my right arm.
Your right arm? Okay.
yeah.
So the front of your right arm takes about 4.5% of your skin surface area along your body. So when we have to actually analyze you for burn damage, we look at these particular areas. So the front of your arm, 4.5%, right? So if we were, for example, to look at per year, if you were to lose about 0.8% of your skin on your favorite arm, Brittany.
Is that a threat?
It's not a threat. It's not a threat. I would never burn you on recording days. You're safe. You're safe.
Okay.
The point is, Brittany, is that it would take 5 or 6 years for you to lose the entire front of your arm from burns per year, right?
Right.
Now imagine that as fresh water, the most valuable and sweetest of resources.
Oh, yes. Very valuable resource.
It's a lot.
That is a lot.
Over time.
Yeah.
Populations obliterated. we've lost this, and it becomes an arid zone, and then people are sad, and then we have dune happening here on Earth because we have to now acquire all the water in order to try to make some type of last-ditch effort to change the entire biodome. Okay.
Yes.
But before that, let's look at further investigation and analysis of the atmospheric CO2.
Okay, so another thing that scientists can do is measure the atmospheric CO2 levels. So CO2 levels have risen from 280 parts per million by volume to 404 parts per million by volume from the pre-industrial era to 2016. So this is an increase of 44%. And CO2 is a well-known greenhouse gas, and a greenhouse gas is a gas that absorbs and emits IR or thermal radiation, and it accounts for 76% of man-made greenhouse gas emissions. So it is probably the most important greenhouse gas that we are investigating, and it is continually increasing over the years. It's not slowing down. It is accelerating some years, and it's not a good thing.
Now, this is quite a negative thing that has no positive outcome currently for the CO2 emissions that we are constantly aggregating. And the problem with CO2 is that the natural cycle for CO2 to leave the atmosphere is not nearly enough for a counterbalance for how much we put in. Right. So you have them collecting, right? And they just keep sending off, and they're collecting around the globe. So you have the radiation from the sun, the sweet, sweet sunlight that you need to blossom as a plant, what you are. As it comes in, and it starts heating the surface, right? They absorb this thermal energy, and then they just shoot it back continuously back at the Earth. So everything gets stuck, which is why we see all of these particular changes over time for the average temperature.
Right.
Right?
Yeah. And it's a problem too because the CO2 that we keep emitting year after year after year just continues to accumulate. So carbon dioxide is a very, very stable molecule. It doesn't spontaneously break apart into other things. You need to put energy in order to break it apart. So it will just keep floating around in the atmosphere, and we'll keep putting out more CO2, and it just gets worse and worse, and then more and more thermal energy will get caught, and the temperature keeps rising, and then we have where we are today.
It's quite the acceleration. And I believe some pinpoint areas can be observed, such as France recently.
Oh, yeah.
Wow.
Really
that must
hot
be
there.
scorching.
Yes.
Our condolences go out to France.
Oh, for sure.
For the heat.
I remember reading somebody talking about how they were in southern France and they had some friends visiting from Botswana, and their friends from Botswana were like, holy fuck, it is hot here.
Yeah. But that's okay. At least there's some people working on CO2.
There are some people working on CO2
yes.
reduction. I don't know any personally, but
all right,
yeah,
fine. If you don't want to out yourself, I won't out.
Too late.
One of the things that we can also measure besides CO2, which we'll get into CO2 more later.
Yes.
I have some hilarious stories.
Yeah. Yes.
Is one of my favorite things, especially being from Florida, feeling my wet, naked body in the rain, flabbering around. Listen, you don't know what it's like to run in the heat out there when it's just smolderingly hot, okay? And the humidity is constantly 100%. And it rains, and you have delicious cold rain slathering your body. You don't know what it's like, Brittany.
Okay.
Trust me.
Yeah.
When we go to Florida, if it rains... No.
Okay.
Anyway, so we have precipitation changes that we can observe.
Right. So in the U.S., there's extreme precipitation changes that have been observed over the last century. So overall, precipitation has increased in the Northeast, the Midwest, and the Southern Great Plains, and decreased in the Southeast and Southwest. So we'll get into that a little bit more about what the consequences are, but if you live in any of these regions, you could probably observe what is actually happening. So Southwest having a lot of droughts, and then Northeast having a lot of extreme hurricanes, for example. This is something we'll delve a little bit more into, but there are concerning precipitation changes in this country.
There's been quite the amount of rain, and it has looked almost tropical out in the woods lately.
Oh, it really has. It's been vibrant and beautiful, but
luscious.
yeah.
but certainly not healthy for the ecosystem.
Oh, absolutely not.
Now, the other thing that will drastically change the ecosystems around here, even though we might not think that a little bump on the thermostat inside of our house makes a big difference, the flora and fauna that is capable of altering just because of a slight temperature change is vast.
Right. Yeah.
So, one of the things that we can look at is these temperature variations, where a lot of, say, doomsday hypothesis for climate change is not that it'll be so severe that we can't live, but that the changes, especially in temperature, will be so fluctuating from year to year that we'll be incapable of biologically being able to handle that. And not just us, but all of our food resources.
Oh, yeah, for sure. Yeah, it's probably the most concerning thing that we're looking at is the temperature change.
We even talked about this when we were discussing faraway possible Earth-like analogs that we could live on.
Exactly. That was a very important parameter for that.
The variations, if they're too extreme, will be incapable of withstanding complex life that would be able to support entities like us. So these temperature variations, how are they changing with this climate change specifically?
Yeah, so scientists could actually look at this. For example, scientists at NASA's Goddard Institute for Space Studies have conducted ongoing temperature analysis from 1980 on, and they found that the average global temperature has increased by about 0.8 degrees Celsius or 1.4 degrees Fahrenheit since 1880, with 2/3 of the warming occurring since 1975 at the rate of roughly 0.15 to 0.2 degrees Celsius per decade.
Wow.
Yeah.
Wow, that is quite the change.
Yeah.
So, per decade, we'll just have to wait and see how hot is hot.
Yes.
How sweaty will we all get?
Oh, so sweaty.
Increasing the amount of water that we need. Reducing the amount of fresh water capable because it's all evaporating. Precipitation alterations where we now have arid zones where we used to have luscious green lands. There'll be nothing left but gasoline and various pockets of clans searching for a safe haven.
So Mad Max is our possible doomsday scenario.
I would like to think.
Okay.
Yeah, or not.
Yeah.
Either way, these changes, we've broken them down, but if you put them all together, that's going to have quite massive, literally global alteration to how we will be able to acquire resources, live, enjoy our lives, future prospects for generations to come, all change just from these small minutiae adding together.
Yes, exactly. So each of these things are devastating as a whole, but when you add them all together, oh my God, we need to do something, and we need to do something now. It's getting bad. I mean, a lot of people heard Bill Nye's very passionate plea about climate change, and he's not wrong. We need to all come together and do something. You hear a lot of people talk about how, well, it's not up to me, I'm one person, but if everybody thinks that, of course nothing is going to get done. So we really plead with people to try to see what they can do individually.
They can clearly change just at least one parameter, right? So if they actually cared about this and wanted to concern themselves with making the world a better place, you don't necessarily have to think so vast and globally. You can think locally. You can think individually, just doing a small little change.
Right.
Each of those changes help. One of the most important changes that need to be made is definitely on the larger scale corporations. That is some of the greatest origins of our emissions and unfortunate destruction of our atmosphere.
Yes.
But the individual can also help.
Yes. We'll get into what everybody can do a little bit later, but yes, while you're listening to this climate change series over the next 3 weeks, just think about the little things that you can do to help out.
Yeah.
Yeah.
Just one thing. Change one thing in your
Just
life.
one thing.
One thing.
Yeah.
I think that's easy.
Yeah.
We can do that too, Brittany.
Oh, yeah.
We'll change one thing in our lives.
I do a lot to try to help.
I mean, I do
Trust
too.
me.
But from all of these things, right? So the hurricanes, living in Florida for quite some time, having to see the changes in the ocean, the tides have gotten more severe, such that the increasing amount of times we've had to dredge and pull sand back up just to keep all of the land from being destroyed and losing home after home, right? Beachfront property has now become underwater property, and now we have new beachfront property.
Yeah.
So on one side, if you invest early on the inland of Florida, you'll have beachfront property eventually.
Eventually, yeah.
But we're spending a lot of money trying to, unfortunately, losingly, battle that a little bit by dredging the coast constantly.
Yeah.
So I've seen that as an increase in some of the intensity, as well as the amount of hurricanes that will inevitably come through because of.
Yeah, so that's kind of the problem with one of the weather patterns that we're starting to see is, of course, Florida gets hit with hurricanes, but now a lot of these coastal cities are starting to see more intense hurricanes. So the reason for this is that higher temperature means higher coastal inundation levels, which leads to an increased chance of tropical storm development, higher rainfall, and a higher proportion of Category 4 and 5 storms.
Which all compounds together, right? So you have salt marshes that are along most of the coastlines, right? Which is why they're so protected by our government, is they do what's called CO2 sequestering. And once you start destroying those, it emits, oh man, just tons and tons of CO2 because you have all these plants holding it in, right? And they're keeping it from being in the atmosphere, and it slowly releases over time, but you have an increasing growth of the salt marshes, which allows for continual sequestering. And in fact, if you live near the coast and have land, you can actually plant saltwater marshes and get credits paid to you by the government for simply sequestering CO2 because it's increasingly becoming a problem.
Okay, government credits.
There are the eastern coastline where you have some of the more agricultural islands in Virginia.
Yes. They in Virginia.
They in Virginia are actually facing some of the problems where you have saltwater inundation in that area where they can no longer grow agriculture enough to sustain a profitable business, and they don't have enough money in order to relocate because a lot of them are merely farmers where you have land tenants owning the land. So these people are being shucked out of their jobs because of that change.
Wow.
And this is, of course, hitting a whole bunch of communities, not only here in the U.S., but also in other countries as well along the coast, because they're losing their livelihood. They're losing their capabilities of acquiring fish, which, mind you, the fish are a big concern.
Oh, yeah.
We'll talk about the fish.
We will talk about
big
the fish.
Concern.
Yes, very big concern.
So you have all of these alterations to it. But what are we going to do?
Yeah.
I don't know.
Yeah. I mean, and that's not it for, the problems with the new weather patterns. We can also look at like sea level rise. So sea level rise as minor as 1 foot greatly increases tsunami hazards, meaning that even small tsunamis can then be destructive as large ones. Yes. And in addition, while some areas of the world will get wetter, others will get drier, which leads to more intense droughts and wildfires in certain regions, such as California and Australia.
Poor Australia.
Oh, yeah, poor Australia.
Feel so bad. We really need to travel there and do more shows there.
Yeah, we should. We
should
totally travel to Australia.
Definitely.
Yeah.
Doing shows for the PRT.
Yeah.
One thing I do want to do in Australia, right?
Right.
So once we go there, I really want to dive and see some of the beautiful coastal lands.
Right.
I'm worried though, because especially coral areas are constantly being degraded by the increasing acidification of the ocean, Brittany.
Yes, the ocean acidification is a major concern right now. So when you increase CO2 levels, this will cause the ocean pH to shift from slightly basic to pH neutral conditions. So it's not actually an acidic ocean, but it's a neutral ocean. And the average global ocean pH has decreased from 8.25 to 8.14 from 1751, with a 30% increase of H plus concentration. So this leads to coral bleaching, shell wear on ocean life, behavioral changes in marine organisms, and food web upheaval.
And if you don't like the Great Barrier Reef, I don't know what you can enjoy in this world.
Yeah, I don't know. I mean, some people hate everything.
The sweet zooxanthellae, all brightening our lives with the colors under the water, all being etched away because of this increasing pH level.
Right.
Sad. And mind you, if we were to have that pH change in our bloodstream, the 0.11 pH change, dead. Immediately dead.
Dead, yes. So it may not seem like a large amount, 8.25 to 8.14, but it is severe. Lethal, yes.
It's destroyed several of the sensory glands capable of many of the marine organisms as well.
Yeah, it has.
Truly sad.
Yeah.
So now we have this ocean acidification and the rise of water, right?
Right. So we also have, in addition, we have the ice cap melt. And we already talked about the sea level rise, but the ice cap melt and the sea level rise are interconnected. So, of course, you have this frozen water. It starts to melt. It adds into the ocean. It raises the sea level.
So what you're telling me, ice caps are melting.
Yes.
Sea level's rising. Ocean is being acidified.
Yes.
Rainforests are being destroyed.
Yes.
The temperature change is destroying the habitable areas for certain animals.
Yes.
If you were to care about any animal, let's say you don't care about humans, right? If you were to care about any animal,
anyone,
any single one of them, then clearly we have to change something in order to save and salvage some of these animals.
right? Because, of course, these upheavals to their ecosystems are leading to mass extinctions. A lot of animals are starting to die off. A lot of animals are becoming more and more threatened, more endangered. And honestly, once we kill off our ecosystem, how are we going to survive? Honestly, the earth will be okay without us, but we're next if we don't change our ways.
Right. I mean, it'll be very sad that many of the animals die, but there will just be more open niches for biology and to create more life in those areas and expand upon them. So once we're gone, yes, I have no doubt that life will continue to propagate here on Earth.
Yeah.
But, you know, it would be nice to stick around and play a little bit longer.
Yeah, it would. It'd be great.
You know?
And if we want to do that, we really need to make a change.
Play in the sun,
Yeah.
have a little fun. Nothing left to do but smile, smile, smile.
If you say so.
I do. And change exactly what we're doing in order to save ourselves.
Yes.
That too. Smile and change.
Yes.
Yep. Well, that has been quite the rude start to our series, Brittany.
Yeah.
It's been a little rough.
Need a little slap in the face.
A little emotionally charged. I feel the palpitations of my heart beating through my chest, wondering why we can't change more, Brittany.
Yeah. Well, we will get into that over the course of our little climate change series.
Well, I'm excited, Brittany.
Yeah.
Unlike some of the other episodes, we ended on a happy note.
Yeah. This is not ending on a happy
I'm
note.
just gonna keep drinking until things get better. Coffee.
Coffee, yeah.
And then we'll talk more about how we can change things, right? There's got to be some positive thing here.
Yeah. We'll get to that.
Okay.
But for right now, doom, gloom, be depressed, please.
Perfect.
Yes.
And then wait for the next week to hear the rest. So, Brittany, this has been quite the trip.
Yes.
I'm glad that our listeners have joined us for this more morbid episode.
Yes.
But if they have any questions, comments, concerns, or wish to discuss things that they would like to see change, they can always contact us, right?
They can absolutely contact us. You can contact us on Facebook, on Twitter, on Instagram under PRTcast. You can also email us under prtcast@gmail.com.
And, of course, we'll put up the references for all of the things that we talked about today.
Yes, of course. And also, we want to start traveling around and start interviewing some experts. So in order to do that, because we are graduate students living off a graduate student stipend, which isn't a lot, trust me, we need to beg for money. So we have set up a Patreon account. So you can find our Patreon account under PRTcast if you're interested in donating.
That would be great.
Oh, yeah, that'd be great.
I love making this podcast. I don't care what our listeners say.
Yeah, I don't care what they say.
However, it is definitely not a monetarily neutral activity.
No, we sink some money into it, so yeah.
It would be great to have a little bit of support.
Yeah. Mm-hmm.
And of course, we thank all the listeners, whether you donate or not. Yeah. We appreciate you listening. We hope that you tell your friends, talk to us, ask us more questions, and if you have anything specific you would like to hear, of course, reach out to us. And, as we said, this series of Doom and Gloom will continue next week.
It will continue.
And we will be talking about more climbs.
Yes.
More climbs. The changes.
Uh-huh. Yeah.
I think that's it. That's all they get. They have to wait.
They have to wait to see the super clever title.
Wonderful. Well, everybody, thank you for listening.
Yeah.
We've been the PRT. Brittany?
Yeah. Thanks for listening.
And we're out!
Bye!